All right, folks, here are some notes for section 3.3. Let me get it kind of to the right zoom. After you get your notes all set up and watch video one, I want you to put, everything on pause. You're going to try problems 1 through 6. We're going to check in, see if it's clear enough with the amount of notes we have. Then you're going to watch video 2, and you're going to try the rest of the homework assignment. Okay, so video 2 is going to start out with a word problem about this kid standing here taking a picture of the lighthouse. Okay, so when you get to the end of these notes, the end of this video, I want you to try problems 1 through 6. All right, we're going to use this postulate. A postulate is something that mathematicians know is true just based on like fundamental properties. It's not something that needs to be proven. It's something that's so fundamental that they say, hey, here is our starting point. We believe this is true with 100% certainty just because of how basic it is. Okay. Now, what is angle-angle similarity? It says if two angles in one triangle are congruent to two angles in another triangle, then the two triangles have to be similar to each other. So if I made a little drawing over here, let's just start there for a second, okay? So if I had a triangle that looked like this, now I'm going to try to make one a little bit smaller, but try to make it look similar to that first triangle, okay? If I knew that this angle was equal to this one, and I knew this angle over here was equal to this one over here, I would know that all three angles in the triangle have to be congruent to all three angles over here in this triangle because of what they call the third angle theorem. This is the third angle in this triangle, and this is the third angle in this triangle. Well, how many degrees do we have to use up? We have 180 degrees in a triangle for the interior angle. So let's say we use 100 degrees between these two, or better yet, let's make it a little bit more realistic because this is kind of a small angle over here. Let's say we use 130 degrees between those two angles. Well, how many degrees do we use between these two? 130, because these two are congruent to those two, right? Well, how many degrees do we have left? We would have 50 left for this one. So the third angle would have to be congruent to the third angle. And in similar figures, all corresponding angles are congruent to each other, right? And then all corresponding sides are in the same ratio. But we don't need to prove that on a triangle, that the corresponding sides are in the same ratio, because having three angles congruent to three other angles in two different triangles means the triangles have to be similar to each other. So it's our goal to identify the angles that are congruent. So like we have an angle here and an angle here, right? And we have an angle here and we have an angle here. You've got to have two angles in one triangle congruent to two angles in the other triangle. So let's look at an example here real quick. All right. Here's example 1 from the textbook. They just give us two parallel lines. Is that enough information to say one triangle is congruent to the other? No, not really. We've got to look and see what two triangles do we have. So we've got this triangle right here, right? Let me see if I can grab that triangle and move it off of the picture, because it's lying on top of the bigger triangle. And let me highlight the bigger triangle in red. Okay, so here's the bigger triangle. Would they have at least two congruent angles? Well, I think they would. Let's mark them up. So this angle right here, let me put 2 tick marks just to make it real clear here. This angle is equal to that one right there because it was lying on top of that angle right over there, right? Let me see if it lets me move this triangle back over there. Okay, so if I move this triangle back over there, now look where the 2 tick marks are. That's the same 2 tick marks that are sitting in that angle, okay? So that's called the reflexive property. I mean, the angle is the same angle, whether it's sitting here or it's sitting over there. I just slid the figure over, right? Now, that's not enough. One angle is not enough to be saying the two triangles are similar to each other. So I've got to find another pair of angles. And I'm going to claim that this angle right here is similar to this angle over here because of corresponding angles. Corresponding angles, if they're formed by two parallel lines cut by a transversal, they have to be equal to each other. I think in your integrated one last year, at the end of the year, you guys should have talked about that. I'm not saying that in a shaming way. I'm just saying that corresponding angles we picked up in like chapter 13 of integrated 1. I know because we went back in integrated 2 last year, and we went into integrated 1 to pick up some of those concepts. Now, if your integrated 1 teacher didn't talk about corresponding angles, or your brain has completely dumped that information, hey, we're going to have to deal with it. We're just reviewing it right now, okay? So what am I saying? This angle right here is congruent to that angle right over there. Remember, like, let's move this thing back over there, and we're going to see where that angle is, okay? So I put this angle right here, this triangle, I should say. And do you see over there, there's that little 1 tick mark right there? Okay, so let me see if I can move this triangle back over there. Oh, good. Everything's working. I thought it would come apart on me. So do I have angle similarity? Yes, I do. Angle similarity. Now, one of the things they ask us to do is write a similarity statement. This is L, this is P, and this is where Q is right here, right? So you see where L, P, Q is. So what we want to do is we want to write a similarity statement like this. Triangle L, P, Q. It doesn't matter how you start. You could go Q, P, L, P, Q, L, whatever. It doesn't matter what order you start in. But the next part is super important, okay? You're going to put the similarity statement or the similarity sign down. And then since I went L, P, Q, I went 2 tick marks, 1 tick mark, no tick mark. I got to do the same over here. 2 tick marks, 1 tick mark. See, I'm going L, J, and then over to K. L, J, and K. All right? So this is called a similarity statement. It's the second part of the drop-down box on your homework problem. You got to make sure you pick it correctly so you're matching up the corresponding angles. All right? Hey, let's look at another example, and then we'll try the first homework problem together. All right, so they tell me this is 44, this is 90. Then they say this is 47, this is 90. Initially, you might say these two triangles are not similar to each other because I can tell, look, 44 is not the same as 47. However, it might be this angle up here that's 47 degrees. So let's just do 5 seconds of thinking here. If we have 44 and 90, that makes 134. That means this angle up here has to be 46 degrees if we hope to get to 180. Okay, now I'm 100% sure these two triangles are not similar to each other because I can't match up 2 angles in this triangle with 2 angles over here, right? You might say, hey, what about this angle down here? Well, I think it's enough to know that 47 is not equal to either one of these 2 angles to say, look, we're not going to get this angle to be equal to one of these 2 either, right? If you're still uncertain about that, figure that one out. That one's 43 degrees. You can see now that we don't have 2 congruent angles. So I'd say no on this one right here. This one looks like a no, right? Right off the get-go. It only tells me this angle here is similar to this one over here. However, we have this thing called vertical angles. Vertical angles are formed by 2 intersecting lines, and they're congruent to each other every time. So these 2 triangles are, so yes, they are similar. That would be in the first drop-down box right there. And then the second drop-down box, we're trying to match up the corresponding parts. So I don't have a picture of what their options are, but if one of their options is triangle FHG, okay, so I just went from F to H to G. I went 1 tick mark, 2 tick marks, no tick marks. I got to do the same up here. 1 tick mark, 2 tick marks, no tick mark. So is similar to triangle JHK. I don't think that's intuitive. Some people are going to ask me, hey, why am I getting this wrong? And they're going to pick the one that goes KHJ, right? If you had FHG over here, you can't go KHJ now because over here I went 1 tick mark, 2 tick marks, no tick marks. If you start down here with K, you're not matching up corresponding angles. So you've got to start with J because F is congruent to J according to our drawing. See how they have 1 tick mark in them each? All right. Hey, that's it for video 1. I want you to try problems 1 through 6 right now. Okay? Thank you.